before I find anything, this is what I want you to do. I want us to set up what's the sum of the forces in the x direction, and what are the sum of the forces in the y direction, okay? And my goal in all is to find the acceleration. And I want to ask myself, in which direction is this going to be accelerating? If it's moving horizontally, then that means that the only force that's going to be causing an acceleration is a horizontal force. So the normal and weight force would be in my vertical forces, they'd be part of my y. So would the y component of this applied force. So the only force that's causing an acceleration, which would make it move horizontally, is the component, x component, of this applied 10 newtons. So the sum of the forces in the x direction is equal to 10 newtons times cosine 30. And since it's accelerating in the x direction, that's not equal to 0, it's equal to mass times acceleration. Okay, I could go ahead and find the acceleration because I'm pretty sure they gave us the mass, which was, yes, 1.25 kilograms. So I could find acceleration here, so let's do that. So I have 10 newtons times cosine 30 equals 1.25 kilograms times A. So if I do that, acceleration, what is that? So 10 times cosine 30 would be 8.66 newtons. And then divided by 1.25 would be 6.93 meters per second squared. So I answered the first part of that question. 6.93 meters per second squared. And I answered it because I set up the sum of the forces in the x, which is what's causing an acceleration, because all of the y forces would be at rest since we're not accelerating vertically. So now the next part of that question was, what is the magnitude of the normal force? What is the magnitude of the normal force? Okay, so normal force we know is directed in the y, so I need to deal with all of the forces in the y direction. Let me actually make this a little smaller. So the sum of the forces in the y is equal to, I have the normal force, and that's directed upward, so I'll call it positive. I have this applied force, so plus 10 newtons, but times sine 30. So there's my applied force. But then that's going to be subtracted from the weight force, so minus Fg. And since it's not accelerating in the y direction, I would consider that to be at equilibrium, so it's equal to 0. I know that weight force is equal to mass times acceleration due to gravity. We know that the mass is 1.25 kilograms. And then we know that acceleration due to gravity is just 9.8. So if I did that 1.25 times 9.8, that would give me 12.25. So this right here is 12.25 newtons. So I have normal plus, and then 10 sine 30, is that 5 newtons? Yeah, so it would be 5 newtons, and then minus your 12.25 newtons. So then let me just move these over here on that side so I can figure out what the normal is equal to. So I can add over here 12.25, subtract over here 5, so then my normal force should be 7.25 newtons. Okay, one of the really big errors, or what I see a lot of, is that most people like to assume that the normal is always equal to the weight force. But that's not true, and we can see that in this case. Because there's a y component of the applied force So I always have to write out the sum of the forces in the y, the sum of the forces in the x. As long as you always do this, I promise you'll get those problems right, okay? Let's do another type of problem here. It says find the tension in each rope as a function of the angle. So I want to find the tension in this rope, I want to find the tension in this, and I want to find the tension in this. And let's assume this would be 30 and this is 30 over here, okay? So I have 30, 30, and then this was a 5 kilogram block. And I want to find, let's call this let's call this T1, let's call this one T2, and let's call that one T3, okay? We'll just go ahead and label them ourselves. It's so easy when you have a problem like this with 3 different tensions that you're trying to find. This would be how I would set this up. I would always find T3 first, the one that's actually attached to the block, okay? So if I do that, I just want to think about the forces that are acting on this block because it's at rest. So first of all, this block has a weight force. And the other force that's acting on it would be then T3. And because this block is at rest, these two vectors should be equal to each other. And I already know the mass of this block. So I could find the weight force. So if I know that mass is 5 kilograms, and I know that the acceleration due to gravity is 9.8, I could go ahead and find the weight, and if these two are supposed to be equal to each other, then T3 must just be equal to the weight. So this would be 49 newtons. And the reason that I know that these are equal, because I want you to set this up. The sum of the forces in the y direction is equal to. If you don't show me this, I'm giving you a 0. You have to show me the sum of the forces in the y, or you have to show me the sum of the forces in the x. It's imperative that you write these. So I know that the sum of the forces in the y will be T3 minus the weight force. So the tension minus the weight force. Since it's at rest, it's equal to 0. The reason that I can say then that the tension in the third rope here is equal to the weight force is because T3 now equals F sub G. I don't ever want you to assume. I want you to write this first. You have to show me that. So because of this, if I found the weight force 49, that means T3 also equals 49 newtons. So we found this first piece. Okay, now I need to find the tension in T1 and I need to find the tension in T2. Okay, so now when I look at my free body, I just want you to think about kind of just this intersection point of where they are. So I have T1, T2, T3. So here's my 49 newtons, and then each of these are at a 30-degree angle here. Okay, so I'm going to make my triangles look like this. So if 30 degrees is here, then 30 degrees should be right here. So then my 30 will be here. And this is, we call that one T1, we call this one T2. Okay, so let's set up just a sum of the forces in the x, and then let's also set up a sum of the forces in the y, and see if we can't solve for T1 and T2, okay? So sum of the forces, first of all, in the x. So I have T2 times cosine 30. That would be here. And then I'm going to subtract that from T1 cosine 30, since that's in the negative x. So minus T1 cosine 30. And again, these are my only x components, and this is at rest, it's at equilibrium. So this should be set equal to 0. So if I simplify that down, T2 cosine 30 minus T1 cosine 30, equals T1 cosine 30. Which really then is just saying T2 equals T1. So now let me come over here and do my sum of the forces in the y, because that really didn't get me anywhere. So sum of the forces in the y would be T2 sine 30 plus T1 sine 30 but minus 49 newtons. Because these are all of my forces that are acting in the y direction. I have a component in the y of T2, a component in the y of T1, both of those are positive, but then I also have the weight force, or this T3 down here below, which we already found, that was 49 newtons, and since all of this is at equilibrium, it should all be equal to 0. Well, here in the x, we just determined T2 is equal to T1, because they're at the same angle. So I could find one of these. Instead of saying T2 here, let me just call this one T1. So T1 sine 30 plus T1 sine 30 equals 49 newtons. So really I could simplify that down and just say 2 times T1 sine 30 equals 49 newtons. Okay, so 2 times T1 sine 30 equals 49 newtons. If I simplify that down, I should get T1 to equal oh no, calculator's broken. So somebody tell me, plug in your calculator, tell me what you get here. But that should be your answer for T1. And then because T1 is equal to T2, then that means that T2 is also going to be the same thing as T1. So that's how I would set up a problem here. And usually that's what we're going to do. And this one's an easier one because the angle is the same. So again, it always comes down to, let me set up a sum of the forces in the x, let me set up a sum of the forces in the y, and then we'll probably end up substituting in something. So let's do another example, see what that looks like. Oh, too far. Okay, so here's another example with an equilibrium problem, but at different angles. So this says a traffic light weighing 122 newtons hangs from a cable tied to 2 other cables fastened to a support. The upper cables make angles of 37 degrees, so T1 is with a 37-degree angle, and then T2 is with a 53-degree angle. And that's with respect to the horizontal. It says these upper cables are not as strong as this vertical cable, right here, and will break if the tension in them exceeds 100 newtons. It says, does the traffic light remain hanging in this situation, or will one of the cables break? So this is just like the last problem, only now we have different angles. So let's do this one. Okay, so I want to draw a free body. I have, let's see, that one was 37. Okay, so this would be at the intersection point of all of the tensions. This one was T1, this one was T2, and this one was T3. I actually have 2 free body diagrams, and the reason that I have 2 are because I want to find what T3 is, and I can find that by having the free body of just the traffic light. And then I could think about the free body to find T1 and T2 based on the intersection point of all of the tensions, okay? So I have 2. So let's go back here and draw 2. So this would be for particularly, let's see, this one's 37, and then this one was 53. So this is for the intersection point, and then for just the traffic light itself, it has a weight force. So there's its weight force, and then it has tension T3. Because that traffic light, we're assuming it's at rest, I can say then for the traffic light, the sum of the forces in the y is equal to T3 minus the weight force. And I can set that equal to 0 because I know it's at rest, or at least it should be, which means that T3 is equal to the weight force. They told me the traffic light weighs 122 newtons in the problem. So T3 must equal then 122 newtons. So I have one piece. T3 is 122. Okay, but now I need to figure out what's T1 and what's T2. Okay, so let's do some of the forces in the x direction, some of the forces in the y direction. Let's see what that gets us. So some of the forces in the x direction would be T2 cosine 53